Alrighty, so today we're going to be doing chapter 21 notes. This is the document that you can find in Schoology, and then we'll go over the PowerPoint, which is the answer key. But basically, you're going to be learning your second ever confidence interval. So the good news is the concepts are all the same as before. So that's why I really needed you to know how to do the chapter 18 and 19, because we're just going to be making intervals from now until the rest of the year. So let me show you your second confidence interval ever. It is called a two proportion interval. So that's the name, two proportion interval. And just by the name, you can tell this time we're going to be taking two samples and we're going to be finding the proportion in each of the samples. So, two proportion interval. The steps are the same as always. Let me start the PowerPoint. And F5. Wait a minute. F5. So I know we're about to start going over chapter 21 examples. Okay, this is the PowerPoint. Alrighty, so let's go over the steps of making any interval ever. Step 1, you're supposed to always define the parameter. Step 2, make some assumptions. Step 3, calculate the interval. Step 4, interpret your interval with the wording recipe. Step 5, interpret the confidence level, which is another wording recipe. So now let's go over it for this specific interval, which like I told you is called a two proportion interval because you are taking two samples now instead of just one. So here's how you define the parameters. You can either define your two parameters separately, like you can call it P1, which is the true proportion of, let's just say females in AP classes. And then P2 could be the true proportion of males in AP classes. So you can define them separately. Or I like to define them as one single difference. So I always just like to put them as P1 minus P2 is the true difference in the proportions of females minus males who are in AP classes. So you have the choice of defining your variable either way. The conditions are the same as all the proportions. Randomization condition. Assume we have two random samples. This time, the word independent here is important. You're supposed to say assume two independent random samples. So please type that up on your conditions. The 10% condition is the same as always. We need to make sure that your samples are less than 10% of each population. And then the large enough condition is the same as always, but now you have more work because now you're going to be doing the N1, P1, and the N1, Q1 is greater than 10, or at least 10. And then you also have to check for the second sample, N2, P2, and then N2, Q2. It has to be at least greater than or equal to 10. And so make sure you check both. Step 3 is the formula. So here's another formula you're going to have to memorize because they're not on the formula sheet. So this is the new formula for the interval. Instead of just having one proportion, now you have the difference between P1 and P2. So the difference between your proportions, plus or minus, Z star is still going to be the same thing. And now for the standard deviation, you have this big mess here, the square root of all that stuff. We'll do an example in a minute. And then the rest is the same. You need to interpret your interval. So it's still that wording recipe that says we are blank % confident, so maybe 90% confident that the true difference in blank lies between blank and blank. So that's still the same recipe. The interpreting the level is still the same recipe. You're going to say using this method, 90% of the time or 90 out of 100 intervals constructed will contain the true population parameter. And now here you can call it the true difference, P1 minus P2. So those are the steps, which are the same, and they will be the same for the rest of the year. We're going to be doing 6 or 7 intervals. So this is your second interval ever. And these are the steps you follow. That's just the formula for you have to just memorize it. Okay, so let's just the formula. Okay, let's actually try an example together. So get your calculators ready, get a pencil ready. And again, these are on the notes. that you need to download from Schoology, right here. Okay, so number 1, we take a sample of 250 medical students and find that 15 of them are African American. And then we do an independent random sample, so a separate sample of 400 medical students, and find 20 of them are Hispanic. Let's create a 95% interval for the true difference in the proportion of African American versus the Hispanic medical students. So we're just going to go through the steps like we did with our previous interval. We need to define the parameter. So practice defining your parameter. Like I told you, you can start with like P1 equals and then P2 equals, or I like to just do them as one difference. So I like to just do P1 minus P2 equals. That's what I prefer. I think it's less writing. So I'm going to put P1 minus P2 is the true difference in the proportion of African American and Hispanic medical students. So I guess on your paper, that's what you will be writing for letter A. Define the parameter. I would just put P1 minus P2 is the true difference in the proportions of African American minus Hispanic medical students. And that's the way I'm going to subtract. I'm going to subtract like African American minus Hispanic in that order. So African American is going to be P1, and then the Hispanics are going to be P2. So that's the first step, define the parameter. The next step is to check your conditions. If you printed out the document, I already typed them up for you so you don't have to write so much, but this is what you would be typing up, I guess, if it was a free response question. So the conditions are the randomization, the 10%, and the large enough. So I guess I'll just read them to you. Randomization. The problem says we have, I put assume, but I'm pretty sure the problem said we have 2 independent random samples of the medical students. So we have 2 independent random samples of medical students. Let's assume that the sample sizes, so the 250 that were the African American and then the 400 that were Hispanic, let's assume that those are less than 10% of their respective populations. I think that's what I wrote. And then finally, for the large enough, this is supposed to be N times P hat. I forgot the hat here, but that's okay. So N1 times P hat 1 is going to be the 15 African American students who are medical students. And then the N1Q1 is the complement, so 235 out of the 250 that were, I guess, not medical students. And then you do the same thing for the Hispanics. So for the Hispanic, the sample was 400, and 20 of them were Hispanic, I guess. And then the rest, the 380, were not. So for the large enough condition, you just have to check that your sample is at least, the number of successes is at least 10, and then the complement is at least 10. Okay, now here goes the actual new thing. So now let's actually practice calculating the interval, and this is where we'll need our calculator. So to calculate the interval, we're going to first have to write down the formula, or you're supposed to, I guess, if this was for response or regular school, you show your work by writing the formula. So for now, just practice it. So you start memorizing the formula. The formula for the interval should be P1 minus P2, or P hat 1 minus P hat 2. So write the formula. Plus or minus Z star times the square root of P hat 1 times 1 minus P hat 1, which remember we just call it Q, divided by the sample size for the first sample. And then you have to add, when it comes to standard deviations, even though you're subtracting your variables, like your P1 minus the P2, when it comes to the standard deviations, you always add standard deviations. That was like way back from chapter 16 last semester, or chapter 15. So you're going to add the standard deviation of the second sample, so P2, Q2 over N2. So let's start plugging in some numbers. Like I told you, I'm going to let P1 be the African American, and then I'm going to let P2 be the Hispanics. You can flip them around if you wanted to, and you'll just have like the opposite signs on the interval, and that's okay. But I'm going to do P1 is the African American. So in your sample of 250 students, 15 of them were African American. So I'm going to put 15 over 250, which is the proportion of African Americans in this group of 250, minus my second sample should be the Hispanics. So in a sample of 400, 20 medical students were Hispanic. So put minus 20 over 400. So this is what you're supposed to show your work. Like you are supposed to write this down. The Z star is like the same as always. The Z star, you're going to be doing inverse normal. And then remember, this was a 95% confident. So even though it's 95% confident, you're supposed to do 0.975, comma 0, comma 1, because you're supposed to add the lower tail of the interval. And now you start doing the standard deviation. So the square root of. I guess I changed my fractions to decimals because they're, I guess maybe, I don't know, faster to write. So the 15 out of the 250, that's 6%. So 0.06 times 0.94, which is the complement, over the sample size of 250. This is the African American standard deviation. And then I'm going to add the standard deviation for the Hispanics. So 20 out of 400, that's 5% of these students were Hispanic. So 5% times the complement, 0.95 over 400. Okay, so this time we're not going to actually do it like with the plus and the minus like we did the first time. This time, let's just go straight to the calculator. So you need your calculator. And instead of like individually typing it in, what we're going to do is we're going to go ahead and straight to the two proportion interval function. So let's go find it. So instead of like actually computing that with the plus and then copying it with the minus, let's just save time and go find a two proportion interval. So go find it under menu, stats, statistics, the confidence intervals. Okay, so these are all the intervals that we're going to do for the rest of the year. We've already done the one proportion interval. That was our last unit. Now we're doing a two proportion Z interval. And then the rest of the year, we're going to do the rest of these. Same concept over and over. Okay, so let's do two proportion. Okay, now you have to fill it in with the information given. So the number of successes for your first sample. Remember, I let my first sample be the African American students. So 15 out of 250 were African American. The next sample was 20 out of 400 were Hispanic. And we want 95% confidence. So leave it as 0.95. And then this is going to give you your upper bound and your lower bound. So this is the difference in the proportions, somewhere between like negative 0.02 and positive 0.04. So between negative 2% and positive 4%. You can copy them down as decimals or you can change them to percentages. Either way is correct. So let's copy it.
I navigate to this one because I'm getting a little bit different wording on the two sample Z interval.
You shouldn't be doing a two sample Z. You should be doing a two proportion. So menu, stats, interval, the one that says number 6, two proportion, because these are proportions. The rest, the other ones are from means. We'll do those next chapters. Two proportion Z. Okay.
Mine also doesn't look like that.
Wait, that it looks like that's your answer. Let's try it one more time.
I mean, like, I don't even have the option to put in the confidence interval.
Go to menu, stats.
I don't have the send calculator.
Oh, well, then use one of mine. Oh, what is that? Like an 84?
Yeah.
I don't know. I once knew how to use an 84 like 10 years ago, but I forgot. There is an option.
I mean, it has the two prop interval, but it just doesn't.
I feel like it should be like the same way. It's not asking you to do like successes for N1.
Yeah, I have the X1, N1, X2, N2, and then I just have P1 is either not equal to P2.
No, you chose the wrong one. So you're in the two proportion test. Get out of there and go to the two proportion interval. The test is what we're doing later on this week.
Gotcha.
You found it. Hopefully you'll find it, the one that just says
Yeah.
interval. Okay. So now we would just copy that interval, the lower bound and the upper bound. Here it is. I wrote it as negative 0.02 to positive 0.04. And you can use decimals or you can use percentages. Either one's correct. And then finally, to finish off our interval, you need to do the interpret. That's the wording recipe. You have to say, we are blank % confident that the true proportion of blank lies between blank and blank. So I guess here it is for this specific scenario. We are 95% confident. Yeah, and you have to like write that all up or type it all up. But these are going to be multiple choice questions like on your next test, since that's easiest to grade. Okay, right now that we're online. So letter D, I would say we are 95% confident that the true difference in proportion of the African American and Hispanic medical student lies somewhere between negative 2.6% and positive 4.64%. So there's like a very small difference. So most likely they're about the same proportion of African American and Hispanic students that are in medical school, because that's a very small difference, negative 2 to 4.6%. So you would interpret it that way. Next, interpret the level, like what does 95% mean? Remember, you say something like, using this method, 95 out of 100 intervals constructed will contain the true difference. Or what did I put here? I said, using this method, 95% of the time, the intervals constructed will contain the true population parameter, or you can just say the true population difference, or you can just flat out say like P1 minus P2. And that's how you make an interval. That's how you make your next interval, your true proportion. Now I need to show you a little bit of what we did on chapter 20. Now we need to use this interval that we just made to determine if there really is a difference between the African American and Hispanic medical students, or if we don't have enough evidence to prove a difference. So that's going to be on your paper, letter F. So let's finish writing this. I'll give you a minute to start reading letter F and letter G while people finish copying this. Ready. All right. So let's finish off the first example and move on to letter F. All righty. So we kind of did this already on chapter 20, using an interval to do a hypothesis test. So letter F. Is there evidence to conclude that there is a difference in the proportion of African American and Hispanic medical students? So you explain using your interval. So if you want to test to see if there's a difference, we're supposed to do a hypothesis test, which is actually going to be a whole another lesson on Wednesday about hypothesis tests. But let's go ahead and try one now. Step 1, if you want to use an interval to prove if there is a difference, you first write some hypothesis. The null hypothesis is we assume there is no difference. So we assume that the proportion of African American medical students is equal to the proportion of Hispanic medical students. So you can just put P1 equals P2. This time, don't use the hat anymore, because P1 and P2 are going to be representing like the true proportion of all Hispanics and all African American. So don't put the hat. The alternative here just wants to know, is there a difference? So it doesn't say which one's greater or which one's less. So we can just put not equal to. P1 doesn't equal to P2. I'll teach you more of this on Wednesday when we do our actual hypothesis test. But another way to write your hypothesis is, instead of putting like P1 equals P2, so the proportions are the same, you could write it as the difference between P1 minus P2 is equal to 0. Because if I just, like basic algebra, if I move this P2 to the left with the minus sign, you end up with P1 minus P2 equals 0. So that's another way to write your hypothesis. And that's actually how I prefer to write them when I actually do the hypothesis test on Wednesday. So P1 minus P2 is equal to 0. The alternative would be that the difference is not equal to 0. And then, like I told you, this has to do with chapter 20. So here's, I guess, what I would call like the how to interpret your interval. So this would be like, I don't know, like the recipe. If the null hypothesis is contained in the interval, then you don't have enough evidence to reject it. And if the null hypothesis is contained in the interval, so in this case, if 0, which is your null hypothesis, if 0% is contained in the interval, we don't have enough evidence to reject the null hypothesis, and we don't have enough evidence of a difference, since it's possible that the true difference is actually 0. So in this case, this is exactly what I was talking about earlier. So your interval was from negative 0.02 to positive 0.04. So that means that there's a chance that the true difference is actually 0. So there is a chance that the true proportion of African American and Hispanic medical students is the same. So there is a chance that the true difference is 0. So therefore, that's what I'm going to put for this scenario. Since 0 is contained in the interval, or you can say since the null hypothesis is contained in the interval, we do not reject the null hypothesis. We failed to reject the null hypothesis, and we don't have enough evidence that there is a difference between the proportion of African American and Hispanic medical students. So in other words, like I told you, based on that interval, it's likely that the proportions of African American and Hispanic medical students is about the same. So you can write that down. And then letter G, I taught you that in chapter 20. What is the significance level? Let me see if I showed my work. Yeah, I did show my work on this one. Let me just finish it off and then I'll stop the video. And that's the end of today's notes. The next example is just you doing the same thing. So let me show you this one and then we can stop this video. The significance level for this specific test should be a whole 5% because the interval was 95. So I put that in the middle. There is 2.5% on each tail. So the top tail is 2.5 and the bottom tail is 2.5. My hypothesis here, the HA was a two-sided, which is called a not equal to. So I do want to include both the upper tail and the lower tail. And that's how you interpret that. I'm going to go ahead and answer questions, but now you can try number 2 by yourself.